Hello and welcome, everyone. Thank you for joining today's discussion on discovering innovative strategies to mitigate configuration risks. We have some real industry veterans here today to lead our discussion, and we're excited to hear your insights and stories on today's topics as well. So at the end of our panel discussion, we will open up about 10-minute Q&A, but if you have any questions during today's session, please do not hesitate to leave your questions in the chat box here and we'll make sure it's addressed. Let's begin by introducing our speakers for today, starting with Charles. Charles Betts leads Forrester's Enterprise Architecture Priority, providing guidance to enterprise architecture professionals worldwide on evolving relevant, modern, and valuable practice. He is deeply engaged in researching the transformation of the IT operating model, in particular, the impact of agile, DevOps, and product thinking. He has previously led Forrester's DevOps and enterprise services management coverage. Prior to joining Forrester, Charlie was a chief architect with AT&T's Signature Client Group, where he was responsible for technical strategy for Fortune 100 clients. He served for 6 years as lead enterprise architect and VP for Business of IT Architecture at Wells Fargo. Charlie's also held architect and product management positions at Best Buy, Target, and Accenture. We also have Sasha Gillenson. With over 25 years of experience, Sasha is the founder and CEO of Evolven Software, pioneer of IT operations analytics, and expert in addressing the chronic configuration and change challenges that have undermined performance, security, and compliance in IT operations for decades. Prior to founding Evolven in 2007, Sasha spent 13 years with Mercury Interactive, now managed by Micro Focus, where he became Mercury Interactive's top guru in quality processes and the IT practices domain. He advised numerous Fortune 500 companies on technology and process optimization, and in turn acquired comprehensive and rare knowledge of market and industry practices that led to the creation of Evolven. So, welcome, Sasha. Welcome, Charles. And last but not least, my name is Jim Walkhouse, the moderator for today's session. I recently joined Evolven with over 25 years of experience in the cybersecurity industry, and I'm passionate pretty much about everything defensive in cyber and everything in IT technology. So let's get started. Charles, you're up.
All right, and thank you so much, Jim. Thanks for having me, Sasha. Great to be chatting with you again. Let me just bring this up, and how's that looking? I'm
Looking good.
assuming it's going through. Great. So I update this slide every so often, and it's always a little depressing to think about the recent things that have happened. And the evidence just keeps mounting that digital systems are increasingly socially, economically, and even life critical, and yet they are fragile and vulnerable. I mean, we've had health systems taken offline by hackers. We've even had people unfortunately die because their hospital was taken offline by a hacker. We have critical infrastructure under attack. And just in the past week or so, there's been a wide variety of news coverage related to some file transfer software now that seems to be implicated in a lot of compromises. But I think the key thing is that with these systems, increasingly society depending on them, the question of how they are secured and how we have assurance that they are operating correctly and in a protected manner becomes so important. And this is all in the context of tremendous changes in IT practices. For example, people will say, well, the old ways, the old concerns, it's all in the cloud. I mean, isn't the cloud more secure? And well, the cloud may be more secure in certain dimensions, but there is absolutely a wide variety of concerns and responsibilities that the modern digital operator must be cognizant of. The cloud, we are moving more and more critical workloads into the cloud. These environments move fast. They have well understood control planes and interfaces. This means, anybody who understands the fundamentals of how that cloud service operates can get in and can change and influence your system. And they also will spin stuff up and spin stuff down. And how do you even know that a given workload executed and maybe did some nefarious things? You have shared infrastructure, multi-tenancy. You have a lot of increasing numbers of integration points and complexity. You have CI/CD pipelines that themselves represent a big vulnerability, as we saw with the SolarWinds breach. And ultimately, it all has to be secured in a zero trust manner. On Forrester, we coined the term zero trust, and it remains absolutely an imperative. And we have to then make sure that our cloud engineers are just as up to speed on their responsibilities as the best on-premises engineers have been in the years past. And this all represents challenge and investment and management concern, risks requiring control, portfolio investments. All of that starts to flow as one thinks about the consequences of these challenges. I don't want to go through all of these bullets here, but just to kind of set the stage, I just did, just some high level scan, and it's not difficult to find enumerations like this of all the things that can go wrong. You don't configure the operating system parameters correctly. You leave doors open that should not be open. You don't update passwords. Error handling in some cases actually reveals way more than it should, and so on and so forth. I won't go through all the rest except to just especially identify at the bottom with the recent attention to software bill of materials. There's more and more concern about, do we even know what's running, what's inside a given container image or workload? Do we understand its security posture? All of these problems are being very actively discussed and investigated, and increasingly served by various actors in this industry, vendors, as well as nonprofit organizations like the CNCF and consultants and advisors. It's a lot of attention to these topics currently. Containers alone, what's in there? Do you have the correct license to run it on the hardware that you are running it on? And is the software in it known to be secure? Do you have provenance? Are you able to demonstrate what equates to chain of custody, for that container image? Ultimately, it does come down to a question of visibility. You can't protect, you can't secure what you can't see. And that's why it was very interesting to me that I was reading a Cloud Security Alliance survey that mentioned 60% of respondents indicated that insufficient visibility to the gaps was a top challenge, and it was by far the most frequently cited problem by a factor of 4 or so. So how is it that we can achieve this visibility we need to secure these systems? Well, the concepts have been around for a while: configuration and change management. Now, just to kind of provoke the discussion, I've superimposed these terms over a picture of a radiologist inspecting a couple of x-rays, because I think that we are at a level of almost biological complexity in our digital systems. And yet we see the same premises and principles applying even in the medical field. The configuration of an organism, the configuration of its bones and organs and nerves and blood vessels, this can be seen as a configuration. We achieve visibility through imaging, in this case, and traditional X-ray, but there are other forms of imaging like MRIs and CAT scans. And then the expert in the imaging compares them and says, the bone is healing nicely. Or perhaps we're seeing changes that are indicative that maybe there is a health issue that is growing. So you look for the configuration, and then you look for, over time, how is that configuration changing? And that fundamental premise has been around for a long time and doesn't change. How we achieve it in digital management, though, remains an evolving and, in many cases, very challenging topic. I've been studying configuration management now for 22 years. It started when I was building something called a metadata repository, a long since outdated term. And a friend of mine came up and said, what's the difference between a metadata repository and a configuration management database, a CMDB? And that single question, as sometimes happens in one's career, informed 20 plus years of investigation of a problem that has never ceased to fascinate me. And ultimately, at the highest level, does come down to this question of visibility. Do we know what we have? Do we know its most critical characteristics and aspects, and how those are changing over time, and how those are material to the work and the outcomes we are trying to achieve? Now, we've come a long way since, I would say, some fairly naive ideas floating around 20 years ago that we would put all the configurations in a database. Actually, that never really worked because the relational database was a fine place to put in higher level things like assets and applications, but to actually document all of the parameters that one would see on, for example, a physical server, you couldn't put those in a database. Even back in the day, there were too many. And then we had the whole software configuration problem. How are we managing the source code, and how are we building it into artifacts? And so very early on, we started to realize as an industry that configuration management was a pretty badly overloaded term, and yet we can't quite get away from it. So this is how we look at things at Forrester. We say, well, the service configuration is kind of at an architecture level. It's a representation of what's out there. But the software and the element configuration management, this is at a more specific, closer to the metal level. This is where stuff gets real. And all of these have particular purposes and use cases we use them for. At a service level, I need to have a portfolio of my applications and services. I need to have a portfolio of my high-level assets. I need to understand how they're related so that I can plan, I can account, I can report, I can coordinate if I'm making changes, for example. And this is kind of a human-to-human view. At the software side, we have code we're writing that we're building into packages and then combining with infrastructure in releases. And here, the artifacts are the things. Up there in the green in the service, it's a representation. The finger pointing at the moon is not the moon, to quote philosophy. But down in the software world, the thing is the thing. The source code is both data and the artifact we're managing. The artifact is data, but it is the thing we are managing and ultimately deploying over to the elements where we manage state, where we say, hey, the bit was flipped this way or that way. The parameter is X. The port that the service is listening on is 8080. All of those things then represent element management, where we discover the configuration, we provision the element, especially in a virtual infrastructure as code world, but even physically, it still is meaningful to say you provision somebody with a cell phone or a laptop. We discover the state of these provisioned resources, and we control that state of the device for drift. And this is really where things get interesting. If I start to talk about drift management, if I hold a meeting about drift management, I might find that I have a number of perspectives represented at the table, and I actually have hosted these meetings, and I was surprised initially that there were these various perspectives because we had the security people who were concerned about drift from policy. What is the correct configuration to prevent exploits, to ensure confidentiality, integrity, and accessibility of the data? Then we had the application managers and similar folks who had a different point of view. They just wanted to know, is the binary on this device the same today as it was yesterday? Or has it been altered? And if so, can I trace that alteration to a process, such as a change process? And then we had the architects who are saying, what I care about is that we are using the standard approved configurations and product choices. And you can drift from one, two, or all three of these things, but they are a different, and it's a set of three distinct concerns. So as you think about drift management, I think it's important to bear in mind these questions. Drift from policy in some cases is the most immediate and dangerous because obviously that can signify a potential security risk. Now, as we look at the changes in configuration, and I've mentioned that when we see drift in, for example, the baseline of a resource or an asset, we want to have a process to control that. That process is called change management. It's been around for a long time. We have data. Our data clearly shows that organizations that have a systematic change process that effectively identifies risk have broadly better business outcomes. We've done factor analysis and correlations. We see that low-performing tech organizations are less likely to say that their change process identifies risk. They're more likely to say that their mean time to resolve has deteriorated. Leading organizations, the converse is true. They are more likely to say that their change process effectively identifies risks, and they're more likely to say that MTTR has improved. So change management does remain important. It comes in for some grief sometimes, but as you know, potential blocker, and there are better and worse ways to do it. But ultimately, it is about solving for coordination, knowledge management, i.e. audit trails, and risk management. And risk management is what I'm going to focus on here. I believe that in a typical change process, if we look at change processes as they are implemented in large retailers and banks and insurance companies, we tend to see a maturation over time. Even a subjective change process can add a lot of value, especially in smaller organizations where you have the right people at the table who have, seen how the systems tend to react. But ultimately, the subjective approach to change management doesn't scale. When people simply say, I have a bad feeling about this, a famous quote from Star Wars, that only gets you so far. At a certain point, you've got thousands of systems, and somebody's bad gut feel about it doesn't really have a lot of meaning, or at least should be supplemented with more mature approaches, such as understanding the dependencies of the systems. Now, ultimately, this was what we hoped would solve all our problems. 10, 15 years ago, we would build out CMDBs that had all of the dependencies, and then we could walk the dependency tree and understand risk that way. Well, that ran into some issues stemming largely just from the sheer complexity of these systems. We couldn't build CMDBs with all the dependencies in them. And we started to see some very process-based and bureaucratic approaches to change management that caused a lot of concern, and people started to question the value. I'm just going through this big checklist. People are making sure I dot the I's and cross the T's, but is this really helping me understand the risk of this change? And then machine learning came along, and we started to realize, and I think this is where we start to segue nicely over to what my friend Sasha is going to tell us about. We started to realize we don't have to stop there. It's still not a bad idea if you can get your dependencies, documented. I would never say that that's a bad thing. But at the level of complexity we see with digital systems, we need a much more data-centric, analytic, learning, and adaptive approach. And this is the direction we see leading organizations going in. This is the direction we see leading vendors going in. We have to use the power of the computer to give us visibility and help us understand the risk of changes to the computer. And guess what? We have the abilities, we've got the techniques, and we've got the algorithms and the understandings to actually use the computer effectively to manage this control plane, to manage its own control plane. And so we see that, for example, there's a number of these capabilities like source control and the test and build that comes out of your continuous integration capabilities, your artifact management, your provisioning activities, your release management. All of this is throwing off digital exhaust, and there's inputs into it. We're documenting intended state in infrastructure as code, so we're being much more precise. We're not just drawing UML diagrams and telling people, well, follow this high-level set of boxes and lines, and it's very much up to their interpretation how they're going to do that. And you can't analyze that high-level set of boxes and lines for any particular risk very easily. And then we have the classic world of the enterprise service management, where you've got your change history, you've got your digital product, and there's hopefully some understanding of its dependencies up and down, from business outcomes all the way down to, the technical infrastructure, the operational status. All of this can be brought together, and we can start to have much improved visibility and a much more powerful set of capabilities that help us understand what it is we need to do to ultimately deliver the secure, valuable outcomes society is expecting from its digital infrastructure. And this is why I'm so pleased to again be appearing and having a conversation with Evolven, who have absolutely, I think, been at the forefront of exploring these questions in a very systematic and very pragmatic and practical way. And so at this point, I want to turn things over to my friend Sasha, and he's going to talk a little bit about Evolven's approaches here.
Great, thank you, Charles, and thank you for the very positive feedback. So let me share my presentation, and let me start with the short background on the company itself. Evolven was started in 2007. Jim has mentioned at the beginning of the initial introductions. We work with large and medium to large enterprises where technology is a critical piece of their business: financial institutions, insurance companies, healthcare, e-commerce, and so on, telco, right? All this organization depend on technology, and Evolven is typically deployed in this organization. It could be deployed on a really wide scale. We have deployments covering over 200,000 servers and hundreds of thousands of infrastructure devices in the private cloud of a single large enterprise. And the reason I'm telling is just say that we provide an innovative technology. We developed an innovative approach, but it's also innovation successfully validated by the leading enterprises in different industries. It's way beyond the test labs and demos. It's something that is used and proven by these enterprise organizations. We're recognized by various analysts and industry pundits. Just as this year, we're recognized as a hot company by the Cyber Defense magazine, as a digital innovator by Intelix, where the innovator of the year at NDC, and some point of time we also were recognized, for example, by Gartner as a cool vendor. So there is also an independent assessment of our technology and its uniqueness by these industry experts. In terms of the challenges we are addressing, Charles, you were talking about the impact of the configuration and changes of the stability and security of the environments. Just to bring a couple of examples that we see in the industry, and we actually get this feedback also from experience from other customers. Actually, Forrester says that nearly all successful cyber attacks on cloud services are a result of misconfigurations. But we also see, I mean, all of us see in the press, right, outages of such as Facebook and Google and Microsoft and Salesforce. And when if you follow up on these outages, you see like what is the reason, what is the root cause. In most of the cases, it will be misconfiguration, some change, configuration change leading to the outage. The venture bid research says that 81% of the companies experienced the certificate-related outage in the past 2 years. Our experience, talking to these large enterprises, that is close to 100%. Almost every our customer or every organization I'm talking to, when you ask them about the impact of certificates, expiring certificate at some point of time, I think at the recent point of time, cause a problem. And what is interesting is that regulators finally kind of recognized the impact of the changes, the impact of misconfiguration, and started to extend their interpretation of the common standards, right? If you look at the OCC, if you look at PCI, at NIST, when today you go through the audit, auditors not just formally look for an evidence that you do have some change management or configuration management process in place, right? That, yeah, the CI was updated, I have it in CMDB. They actually want to see that you are able to use the data, recognize the data, reconcile the data, make use of the data, not just keeping it in CMDB, not just keeping it in your service desk, but actually actively using it to manage your environment. So what was even a few years ago, where you would put a change tracking software in your environment and print a report showing that, hey, I know all the files that changed because I have a file integrity monitoring platform in place. Today, this doesn't work, right? Because the auditor will ask, okay, I mean, I have the list of this, all these changes. What do they mean? Like, how do you use them? What can you, what kind of conclusions, right? You draw from this information that you have. And I think that's a major shift in the regulators' approach that is very important for all the regulated industries. And the configuration, could be anything. We talked about the certificates, it could be configuration files, it could be application artifacts. I mean, Log4j scare, right? Happened not so far ago. And after that, we had a Spring4 shell scare and many other scares, right, related to the libraries, the open source libraries that were found vulnerable. And due to their wide use, identifying all these libraries, where they are, what versions you have, what uses what, is really complicated problem. But if you look at this as part, right, Log4j is just another element of the configuration. And if you are able to control your configuration, then you will be able, easily find the vulnerable libraries and replace them. So these are just a few examples of common configuration and change related issues, and the risks the change in configuration creates that could be actually avoided. So how to avoid them? We have developed an approach, strategy that we call configuration risk intelligence. And the foundation of this strategy is actually an approach looking at the data of configuration and change together, right? There are a lot of tools that look only at configuration, or look only at changes, and actually referring to ITIL, getting a bit outdated. They have the configuration management and change management a separate process. There is certain linkage happening in the latest versions of the ITIL, but still it's not a consolidated set of data. Now, why do you need to look at both sets of data together? Because they are two sides of the same coin. I will give an example. If you look just at your configuration and you ensure that your configuration is compliant, there is no drift relative to the, for example, compliance policies such as CIS benchmark or whatever, regulation or compliance you are following, everything is fine. But then an unauthorized change has happened. And you know what? The unauthorized change, updated, let's say, a configuration parameter to the value that is still compliant. So does it mean that my environment is safe? Does it mean that my environment is going to be stable and secure? It's not, because unauthorized change has an inherent risk by itself. Even the value is fine, right? The fact that someone made a change without going, through the process, there is no change request behind, or if you're following an agile process, there is no story, no epic, right? That can justify this particular change. You still have risk in your environment until you review and reconcile this change. At the same time, you can have approved, authorized, automatic changes going across your environment. And let's say that you are updating, a set of servers. It's still server-based environment. And, out of 100 servers that you updated, you had 99 were updated, as the hundreds were not updated. Does it change? I mean, it's fine. It's approved. It's delivered. It's completed. But now there is a drift in configuration where, we have one server that is different from 99. So you cannot really look at it as a change, because the change properties could be fine. You cannot look at only as a configuration, because they could be fine as well. You need to look at both sets of data to ensure that all the risks related to configuration and change are identified effectively. So once you have this foundation, once you have the set of the data, we suggest following 5 steps of identify, verify, monitor, analyze, and act. We got a very, I think, straightforward and common sense based steps. Identify, of course, you need to collect this information. This configuration, you need to get information about all your assets in your environment, about their detailed configuration, how they look, what are all the components, again, the most granular level. Because once you have this data, you can verify it and ensure that your configuration is kind of consistent, it is compliant, it matches target standards, your best practices. So you start from a good place. Now, once you do that, you can start tracking the changes. You can start monitoring, right? And you can see what are the changes and drift happening across, your configuration state that you verified as a previous step. Now, having, information about the configuration and knowing all the changes, you get a lot of information, right? We have customers like large enterprises, like banks or insurance companies, where we track millions of changes per day, of granular changes per day, millions. That's a lot of information to make sense or to act upon. So you need to analyze that. There should be a way to analyze the data and prioritize it based on the risk, because risk is a leading indicator for prioritization, right, of a misconfiguration or change. Identifying these risks that can potentially lead to stability, compliance, and security issues. Because again, once you are able to prioritize, say, this change can cause an issue, this configuration is not good, it can lead to the issue, then you can take an action. Because knowing risk and understanding the context of the risk, you can take an action that will mitigate, will avoid the risk, and could be, you remediate a bad change, you repave your environment if you have immutable infrastructure, you do additional review, right? If you are detected risk in the code while the change is going through the CI/CD pipeline, and you can increase your monitoring frequency, you can add monitoring. So all this information about the risk can help you select the most effective action. So identify, verify, monitor, analyze, and act on the data combining configuration change. That's the innovative strategy for mitigating risks that we are suggesting to the market, to the industry. Now, behind it, this is a conceptual strategy, but how to implement it, right? So we have developed technology that supports this approach, this model that I just provided overview of. So there are 2 major capabilities that this platform is based on. First one, collection of information, so like identified. So identifying manually, it's definitely not an option, particularly in this complex environment, and the level of complexity, Charles mentioned that, the level of complexity is tremendous. So you need to be able to collect the configuration as the most granular level, end-to-end, from application to infrastructure. We talk about the enterprises, they all have hybrid clouds. They have on-premise legacy software, modern software, they have private clouds, they have public cloud, it all works together. Today, any enterprise we talk to, they do have hybrid cloud. I mean, again, their transition to cloud could be a different degree. There could be 5% of so applications move to cloud, 10%, 15, 20, 50. It depends, but it's always hybrid cloud. So you need to cover this hybrid cloud end to end. That's what we're doing, collecting very granular information very frequently with controlled minimum overhead from application down to infrastructure, from on-premise to the cloud. Now, again, collecting all this information and tracking, having actual configuration in near time, actual changes, to analyze that, we apply combination of machine learning, heuristic, statistic algorithms, user-defined policies, searches, and also we can integrate all the data we collect with existing data sitting out there as existing IT management, IT automation, as IT monitoring systems to ensure that we create the integrated the configuration and changes we detect with the context available in the systems, like, for example, service desk or CI/CD pipeline or monitoring tools. We can stitch all those together by creating this kind of operational or security awareness, from starting from what was planned, what was intended, what actually happened, and what was the impact of the configurations and changes introduced to the environment. And what was planned you can find in CI/CD pipeline, in service desk, in other places. What is the impact you can find in monitoring tools, and what actually happens. That's what Evolven brings in terms of the unique data set to the table. Now, having this platform, we can provide, we can support a set of the use cases mitigating different types of the risk, configuration-related risk, change-related risk, and it could be from configuration asset inventory management, the configuration baseline management, which is part of many regulations, certificate assurance. We talked about the certificate problems and certificate being part of the configuration vulnerability detection, detection of unauthorized changes, and change audit reconciliation, again, very important for compliance and security. Introducing the risk gateway to CI/CD pipelines. That is actually what this is implementation of this concept that Charles was talking about, the automatic analytics, right? Linking all this as the change control, change management into automated release processes. Detection of the drift, detection of the consistency, root cause analysis, linking the configurations and changes to the incidents that it caused. That's kind of type of it's just a subset of the use cases, different use cases, mitigating different risks that we can deliver on the top of the platform capabilities of collecting information, analyzing it, that I have mentioned. So what is different about Evolven? Like, why we talked about, like, I mentioned uniqueness of the approach, innovation of the approach. What is different? Different is that we are providing a single pane of glass, a unified view of current configuration state, its history and evolution by looking at configuration and changes together, right? And that's, again, something that doesn't really exist in the industry, linking these two data sets together, looking at the hybrid multi-cloud end-to-end as the most granular level and near real time. Again, getting the data at this level and this extent is unique as well, and it is a critical success factor for the risk intelligence. How can you estimate the risk? How you can be intelligent about the risk if you don't really know what is the detailed configuration, what are the detailed changes happening in the environment? Now, we also cross, as you could see in the use cases, we cross different silos. We cover security, compliance, operation, DevOps as a single platform, right? And again, today, if you look at most of the enterprises, these teams will be using different perspectives, different tools, different process, even if the organization tries to get to DevSecOps, right? Still security will be looking, at their tools, and the operation will be looking at their tools, but they are looking at the same set of data, just from different perspectives, using different risks. So risk, single platform, shared view, which is risk-based, is also necessary to bring the silos together. The analytics part is very important because we have 6 patents for our AI engine that again reviews all the detailed configuration and changes, identifying the stability, compliance, and security risks. And also this comprehensive approach, looking in all these different use cases that mitigate all these different risks again in one platform. That's also important because you don't want to create a set of 10 tools, right? To deal with configuration and change risks. So to wrap up, as I mentioned, right, the tool, our technology, our solution, our approach, configuration risk intelligence, is used by leading enterprises, and we can say that there is tangible benefits that could be realized from using this approach. And it's about cutting a number of operational incidents and accelerating mean time to resolution. It's reducing the number of security incidents related to the configuration and ensuring full compliance with required changing configuration controls requested by different regulations. So I will pause here and jump for a quick demo. It's like this was just the story and the slides, but I do want to show you the actual product, so you see like what is the capabilities behind the story. So let's start with the asset view, where if we collected all the detailed configuration across the hybrid cloud, we can provide a single point of view into the legacy asset, into the cloud assets, and we can slice and dice and provide different perspective and this asset from because we have very detailed configuration and our entire configuration of this environment. So you can look very basic things like what kind of versions of Windows and Linux I have in my legacy environment, what type of EC2 instances I have, for example, in AWS cloud, or even like a good example, what kind of IAM users with full access I have in my environment. That's very critical, for security aspects. So I can, break again my servers by the size of the volumes, my Lambda functions by the runtime technology used to execute them. Any type of the perspective is possible. And you can actually, again, leverage this tremendous data lake of configuration data lake by finding any answer you want, searching across environment for the configuration change related questions, answers to the configuration change related questions. Like, for example, what I'm doing now, I'm looking across all my discovered environments, and I want to see like a very, again, common case in enterprises. So like, what kind of old, outdated Java deployments I have in my environment. So you can see that the search is kind of very simple. I look for installed products where a name starts with Java, version less than 1.8, and I get actually a list of these deployments and a list of the servers showing me where essentially this old Java packages, all Java deployments were fine. But I can also look at different perspective and say, as I mentioned, like, what kind of Lambda functions I have that are using Python, because I'm migrating from the Python. So I want to know what is using the Python, and I get a list of my Lambda functions. So now we're talking about the modern environment like AWS. Another perspective, again, I do I have any large AWS instances running? Okay, because I may need one. Okay, here is a list of my large AWS instances. You don't need to go to another tool. You don't need to open AWS consoles that you might not have access to. But if you have right permissions, right, to access the data, you can see it in one tool: my legacy environment, my cloud environment, and my Kubernetes environments. For example, I want to see all my Kubernetes deployments with unlimited memory. Again, a simple query: show me all the Kubernetes deployments where memory is not defined, the limit is not defined, and here's all my deployments with unlimited memory. So the point here is that because you have this extensive, granular, end-to-end configuration data lake, you can find any answer to the configuration question. As the other perspective is the kind of also perspective of the change risk. And again, I go to modern environment, I go to my Cloud Ops dashboard, for example, and I look in my AWS accounts, and I can see in my production account different application services, what kind of changes happens there, what kind of AWS services were affected, and the risks that are there. So I see that there is a bunch, 7 risky changes that were actually identified by Evolven Analytics in foreign currency service. If I'm a cloud ops engineer, I can drill down to investigate the risks and actually potentially prevent the incidents. I get to my analysis screen, and I want to see the details of the changes. I picked, a view broken down by cloud services, so I can see like what kind of changes I have in different services. And what I can also do, because I have ability to look at all my changes and break them down, introduce like, different types of breakdowns. I want to see it by automatic analysis outcome. And so what my automatic analysis says that I see the changes breaking compliance. I see the changes that actually significantly decreased capacity, the impacted capacity as a risk, the changes that impact my cost, and some anomalies, for example, with IAM policies, right permissions. So that's interesting. What actually means a particular policy was added and it has right permission. And if I look across environment, across different roles, this permission seem to be anomalous. Or, I have actually here an instance type updated to large. What was it before? It was small. Obviously, I have impact as a cost. Or my IOPS parameter was increased. It was 189, now it's 3,000. Again, there is a cost impact. So this is an example of automatic analysis, looking at different types of risk, applying different, again, ML and statistic and heuristic algorithms to identify these risky changes that you can deal with to mitigate these different types of the risks. The last point I want to show is that, the different perspective could be not from the infrastructure level, but from DevOps perspective, where we can look at the changes going through the pipeline. So dashboard looks again, we're looking at the same set of the changes, the same set of configuration, but from perspective of changes going through the pipeline. For example, we see that there's a backend pipeline, front-end pipeline. We have a bunch of services sharing these pipelines, and we see different stages of the pipelines. And we see actually for service and light server, integration test is red, so risk were detected. I can drill down, and Evolven will show me what are the risky changes. As the risky changes could be coming, from configuration, like Kubernetes configuration. Let's look at this one. I select, this type of change. I see at the bottom the description of the change, that for a particular namespace, for a particular microservice, a memory of container was decreased to 128, and with a gigabyte before. That's not good. And I also can see that the code changes introduce other types of risks. We can see on the right what our out analysis tells us. Other change with frequent test failures. We see the package that was typically is not touched by a new developer, and someone that is no experience as a code in this particular code was updating it. Or we see the change that creates a critical functionality impact. So again, from that point, we can take an action and we can roll back the change. We can, instead of peer review, we can have a team lead review. As I mentioned, we can have increased level of testing, level of monitoring, so you can take an action, right? Once you know what the risk is and where is the risk. I will pause here, and Jim, I'll pass it, the baton back to you if you have any questions from the audience.
Excellent. Thank you. Thank you, Charles. Thank you, Sasha, for the presentation. And I really love seeing the demo at the end there. Charles, let's get you into the mix here after Sasha's presentation. Can you still recommend the ITIL change management process, given where we are in the modern IT world?
Well, it's a big if, Jim. Change management as a process is important. However, the way you approach it is critical. The idea of the change advisory board, especially when it meets on a every other week basis and you see people lining out the door with their changes, and you've got a group of experts in the room who are trying to assess whether a given change is advisable or not, That's just not gonna scale. I mean, maybe it worked back in the day when you had many fewer systems and people, could develop the mental models. Certainly if it was all in the mainframe, I mean, and you had a more constrained environment. But what we see with the classic, if people try to do ITIL by the book and they follow the change advisory board process and they try to scale it up, we see more and more people needing to be on the board, and we see just immense backlogs, and we see delay. And the trouble with digital systems, especially in the modern competitive environment, is that kind of delay can be fatal. So really what we want to see is that there still is a concept of a change. I think that's pretty critically important. And even in DevOps, there's some well-known metrics called the DORA metrics, DevOps Research and Assessment. And one of those metrics has to do with failed changes. Well, if you are tracking changes, to my mind, you have some kind of a change process. I mean, if you have the data on failed changes, it means you're tracking changes. If you're tracking changes, it means you have a change process. But that process can be much more automated. It can be risk driven. It can be federated. It can be decentralized. We've written about this. I've got a report on it, if people want further information. So I'm sorry to, it's kind of nuanced, because I'm never going to say to somebody, you just scrap your change management process. It'd be highly irresponsible. But look at the delay it's causing, look at automation, look at different ways to do it, because the traditional ways don't scale.
Okay, perfect. So that kind of goes into the next question I'd like to ask, which is, Sasha, in your demo, you actually showed a visualization of kind of the CI/CD risk gateway for a DevOps or DevSecOps process, right? Is DevSecOps real? And is it happening in most organizations? And Charles, that can be a question for you. That can be a question for Sasha. You guys can fight. I'm not going to tell you how to do your jobs.
So from what I see, and I'll start, I do have, I think, less exposure to the customers that Charles has, but the customers I'm talking to all believe that this is the next step, DevSecOps, right? And now they see that as you start to shift to DevOps, and particularly when you start to implement agile automated processes, you need to embed security. I mean, security cannot come after so. So conceptually, as I understand that there is some transformation happening, but what I also see is that in most of the organizations that I talk to, it's the only beginning of the way, right? And I didn't see really many organizations. Again, I talk about enterprise, complex hybrid cloud, say like, we have DevSecOps 100%. It's a transition. That's my experience.
Yeah, I would agree. It's very much work in process. I think the important thing again is moving away from security reviews that are after the fact, that are all about trying to catch up with the product or the application team and police them, very checklist driven. You have to go back and do a whole bunch of rework. I mean, nobody has time for that. It's very inefficient. So we need to bake the security into the platform architectures, and where there are things that we need to check, we need to bake that into the CI/CD pipeline, which is itself part of the platform architecture.
Yeah.
And then it's a very different experience. If you from a developer point of view, the thing I don't like is when I have to pause my work and then somebody else, some architect, some security engineer is going to come in and review with a checklist. And I'm sitting there, my hands are tied, I've been told to stop work, I can't move forward on the thing that is important to me. And then it's going to take one to however many weeks, and then they come back at me with a whole bunch of fixes. And this is ultimately just not a good way to deliver digital systems. What we want is we want it embedded in the platform and in the continuous delivery tool chain.
Christy and I have the same problem with marketing collateral, but so you mentioned the CI/CD pipeline and measuring the risk there. Can you kind of dig into that a little bit more, explain what that kind of looks like? Or Sasha, if you want to jump in, how it would work with Evolven. I mean,
Now, I will start with the Evolven side, right? I mean, there are different types of risks, right? What we look is at the risk of specific granular change. I mean, we believe that there is a value in looking as a granular change as it goes through the CI/CD pipeline from commit to actual deployment, and as it goes through different steps, its risk actually evolves, right? And it could be just provide an example. An engineer changed application configuration, right? And it again is within kind of the policies, maybe limits, but as it goes through the testing process, you see that it overutilizes underlying infrastructure, right? So there is the impact on the environment. It's clear there will be risk, could be a risk for the production. You can learn from that, right? And for example, how to adjust, your policies. And B, you definitely want to be aware of that, of this specific change creating this issue, right? So that you can be able to rapidly remediate and update this change. That's just one example of the risk for individual granular configuration that Evolven deals with.
so you talked about learning, and I know that I heard AI during this conversation and things like that. So I'm gonna finish this up with one last question. And Charles, if you want to start with this, what do you think the impact of like large language models like OpenAI and generative AI will do on risk and automation in this DevSecOps arena?
Well, we've seen how Evolven uses existing technology to identify risk, identify outliers, and I think that there's still some really important, algorithmic work that happens there using the technologies that have already been pioneered. The large language models, I think to some extent the jury is out a little bit, but Sasha may have something for us, in terms of the specific use case here. There's very exciting things, but
yeah, because we started, again, as you said, Charles, it's just beginning, right? And jury's out there. But we started to work already with this new technologies and with the opportunity, like leverage the opportunities they provide. And we see a number of use cases coming from being a better interface of communication with your users, using essentially instead of old chatbots that you needed, to train their limited language models, being able to feed as an LLM, right? With the outcome of kind of AI-ready data that you provide, and allow users use native language to query this data, to investigate this data, while LLM and AI, like AI based on LLM, interprets this data, summarizes data, looks for the right data, for the right answers. The communication for the user becomes much more effective and easier, right? The other perspective is that also these models are really good for large data sets. And again, we talked about massive amounts of configuration, massive amounts of changes. So if you are able to train these models on this kind of the data, these models actually help you, to estimate the risk, to actually analyze, look for the root causes, to find potential misconfigurations, and again, to summarize and explain them in a very effective way. It's a lot of work, right? You need the data, you need the training, you need actually to, to feed your specialized data into the generic, connected to the generic models. But the result, again, jury's out, but results look very promising. Actually, we do have a very interesting demo of our kind of initial prototype on our website for those that are interested. That actually shows how Evolven works with ChatGPT.
Very cool. So, Sasha, Charles, everyone who attended, thank you very much for joining today's discussion on discovering innovative strategies to mitigate configuration risks. This video will be available on demand for sharing with your colleagues. I hope you enjoyed today's session, and I look forward to seeing you in other ones.
Thank you very much for the opportunity to present.
Thank you.
Thanks.